everyone. Myself, Dr. Tarkeshwari Verma from CSVTO. Today's lecture topic is the petrology. Today's lecture contains a introduction of the petrology, importance of the petrology, types of rock, rock cycle, petrology methods, mineral identification, petrography and their applications. Let's start with the introduction about the petrology. Petrology is the branch of geology that focuses significantly on the study of rock, including their compositions, origin and classification. It plays a very crucial role in the understanding Earth's history, process and the formation of different rock types. The importance of the petrology in a field of the geology is evident in several ways. First is the rock classification. Petrologists classify rocks based on their mineral composition, texture and origin. This classification is essential for the interpreting geological process and understanding the condition under the rock formed. It's helped in identifying specific rock types and their significance in geological context. Second is the formation process. Petrology provides the insight into the condition and processes that lead to the formation of rock. Third is the resource exploration. Petrology is important in identifying and characterize mineral resource within rocks. Economic minerals such as ores and gemstone are often associated with the specific rock type. Fourth is the tectonic history. Petrology contributed to understand the tectonic history of the region. Different rock types are often associated with the specific tectonic setting, and the study of petrology helps geologists reconstruct the geological history of the area, including the movement of tectonic plates. Fifth is the environmental geology. Petrology is valuable in environmental geology for assessing the impact of certain rock on the surrounding environment. For instance, the presence of specific minerals in a rock may have environmental implications such as the release of harmful elements into the groundwater. Oil and gas exploration. In the field of petroleum geology, petrology is essential for the understanding the reservoir rock that contain oil and gas. Knowledge of the petrological characteristics of the rock help in a field of petroleum geology. Petrology is essential for the understanding the behavior rock of the contain oil and gas. Next is the geological mapping. Petrology is the foundation of the geological mapping. By identifying and classifying rock, petrologists contributed to the certain of the geological map, which are essential for the land use planning, resource management and the hazard assessment. Now our next topic is the types of rock. Introduce the three main types of the rock: igneous, sedimentary and the metamorphic. Rock are classified into the three main types based on their formation process. First is the igneous rock, formed from the cooling and solidification of molten magma type. There are also two types. First is the extractive, formed benches of earth's surface. Extractive, volcanic, formed on the earth's surface from the lava. Second type of the sedimentary rocks formed from the accumulation and dissemination of sediments or organic materials that you also classified in the sometimes. This is also classified in the three types. First is the clastic. First is the clastic. Composed is the fragment and pre-exciting rock. Second is the chemical, formed from the precipitation of minerals from the solution. Third is the organic compounds of the organic material such as the coal. Third main our type of the rock is the metamorphic rock. That kind of rock formed from the alteration of the pre-existing rocks due to heat, pressure or the chemically reactive fluid. They have in it two types. First is the foliated exhibit that exhibit layered or bonded appearance. Second is the non-foliated, do not exhibit any layer structure. Understanding of the type of the rock is necessary to geology because they provide insight into the earth's history, process and the environmental condition. The study of the rock helps the geologist to know about the history of the area. Different types of rocks have variety of properties and characteristics that make them valuable for the various applications such as the construction material, resource exploration and even understanding the potential of the certain geological hazard. Now we are described each type of the rock individually. First is the igneous rock. Famous on the igneous rock. Igneous rock are formed from the cooling and solidification of the magma or lava. The process of the cooling determines the texture and the resulting rock with slower cooling typically producing layered crystal. There are two main types. Igneous rock based on the when there are formed extractive rock from the below the earth's surface and extractive rock from the earth's surface on the surface. Basically they have two types. One is the found in the below the earth and other one is the we found in a earth surface. For interactive rock from when magma cools and solidified benches are in the earth's surface. The slow cooling allows for the development of the layered crystal. Example of the particular that rock is the granite. It is the common example of the instructive igneous rock. It is the composed mainly of the quartz and mica. Granite often forms large indexes called the plutons. Second is the extractive volcanic igneous rock. That kind of rocks form when lava interrupts into the earth's surface and rapidly cool. The quick cooling result is the smaller crystal. Example is the basalt. Basalt is the well-known extractive igneous rock which is rich in iron and magnesium material. Next, the formation process that it is formed. In both cases, the process begins with the melting of the rock deep within the earth due to high temperature and pressure. This molten material called the magma can rise toward the earth's surface through the volcanic activity. As the magma or lava cools mineral being to the crystalline, forming an ingenious rock. The rate of cooling influence the size of the crystal, so cooling result in a layer crystal. Second is the sedimentary rock. That kind of rock formed through the accumulation, compaction. That kind of rock formed through the accumulation and compaction and the cementation of the sediments derived from the weathering and erosion of pre-exciting rock. This process involves several stages of the resulting rock, often the valuable information about the earth history and environmental condition that form by weathering and erosion. Weathering, this is the breakdown of the rock into the smallest particle due to the physical, chemicals or the biological process. Weathering we can occur through the process like freeze thaw cycle, an action of wind and water on the activity of organism. Erosion, transport of the weathered particle by agents such as a wind, water or a ice. River, glacier, wind and ocean current can carry these sediments to new locations. Second is the transportation. Sediments are transported by the various agents like river, wind, glacier and the ocean current. During transportation, that can be sorted and deposited based on their size and weight. Deposition, when the transporting agent loses their energy, they deposit the sediment that they were carrying. This leads to the accumulation of the particulate that layer. Compaction, a more and more sediments accumulated and weight of the overlying sedimented compression the layers beneath. This compaction reduces the pore space between the grain, making the sediment more compact. Next topic is the cementation. Over time, minerals dissolve the groundwater can precipitate and fill the remaining pores space, binding the sediments particle together. This process known as cementation and the solidified in the sediments into the concrete rock. Example of the sedimentary rocks. First is the sandstone. Sandstone is the primarily composed and sand-sized grains, usually quartz and other mineral particles. It's formed when the sand-sized sediments are compacted and cemented together. Limestone. Limestone is often formed from the accumulation of organic remains such as the shell and coral fragments. It can also form chemically through the participation of the calcium carbonate from the water. Limestone can be ranged from the fine granite to coarse texture. Fossils are often present in a limestone. Next one is our topic is the metamorphic rock. Metamorphic rock are the category of the rock that form from the alteration and pre-exciting rock. Due to change of the temperature, pressure and chemically active fluid. The word metamorphosis means the change in a form. The metamorphic rock undergo the changes in the mineral composition, texture and the structure without melting. Formation through the heat and pressure. Metamorphic rocks from the under the influence of the heat and pressure, typically deep within the earth crust. The process is known as the metamorphic and it involves the following factors. First is the heat. Rock is the subject of the high temperature, usually between the 180 to 800 degree Celsius. This heat can come from the intrusion of molten magma, the approximately the hot magma chamber. Second is the pressure. Metamorphic rock experience event pressure, which is the result from the overlying rock. The tectonic forces associated with the mountain building process. Increased pressure can lead to the recrystallization of the minerals and the development of the few minerals elements. Third one is the chemically active fluids. Fluids rich in the dissolved mineral many circulate through the rock during the metamorphism. These fluids can react with the mineral in the rock, causing chemical changes and contributing to the recrystallization process. Example of the morphological rock, first is the marble. Marble is the metamorphic rock and form the metamorphism of the limestone and dolostone. The metamorphic involves the heat and pressure which causes of the recrystallization of the original minerals into the larger interlocking crystal of calcite or dolomites. Marble is known for the smooth and often polished appearance to comes in the various colors depending on the impurity present during the metamorphism. Next is the squirts. This is the morphological rock that typically form from the metamorphic of the shale or other fine grained rock. The minerals into the original rock crystallize under the heat and pressure, resulting foliated structure with the mineral gains aligned into the distinct band. The rock cycle. Our next topic is the rock cycle. The rock cycle is the continuous geological process that involves the transformation of the rock between the three main types. First, main three types of the rock. Rocks changes from one type to the another over the time through the process such as the weathering, erosion, melting, cooling and the metamorphism. The significance of the rock cycle. First is the earth dynamic. The rock cycle is essential of the understanding the dynamic nature of the earth crust and the processes that shape and its surface. Environmental record. Rock provide the record of the earth history including the post climate and the evolution of the life. Third is the resource formation. Many valuable resources including minerals, ores and fossil fuels are linked to the specific stage of the rock cycle. Next is our petrology method. First is the field work. Petrologists conduct the field work to the observe rock and their natural setting. This involves mapping, noting mineral composition and identifying the geological features. Second one is the laboratory analysis. Petrologists use the various laboratory techniques including microscopy, X-ray diffraction and chemical analysis to examine rock sample in a detail. Laboratory method help to determine mineral composition, texture and the condition under which rock formed, contributing to the comprehensive understanding of the petrological process. Another method of the petrological method is the sample collection. Contextual understanding. Collected sample represent the specific geological environments, allow the petrologist to understand the both geological context and history of the area. Analysis accuracy. Quality sample lead to the more occurs laboratory analysis, aiding to the identification of the minerals, texture and the overall petrological characteristics of rock. In a field of research, petrologist research relies on well collected sample to the draw meaningful conclusion about the geological processes, history and environmental condition. Next is the mineral identification. It is necessary to know how to identify mineral and what the process to identify the minerals. First is the observation, observing the minerals external characteristics such as the color, luster and the crystal form. Second is the hardness, determine the minerals hardness using the Mohs scale, cleavage and fracture. Examine the how mineral breaks, whether it has cleavage planes and exhibit the certain time of fraction. Next is the specific gravity. Measure the mineral's density relative to the water. Physical and optical properties. Physical properties include color, hardness, cleavage, fracture and specific gravity. Second is the optical properties. Examine under a microscope using polarized light, revealing characteristics like interference colors. Mineral identification combines the assessment of the physical and optical properties, providing a comparison approach of characterizing and distinguishing minerals. Next is the petrography. Petrography is the detailed study of the rock and mineral using thin section, slice of the rock that are the mounted on glass slides and the examined under the polarizing microscope. This is the many more things to examine the minerals. First is the microscopic examination. Allow for the detailed observation is the mineral composition, texture and structure in microscopic level. Mineral identification. Facilitate the identification of the minerals within the rock, aiding in the determination of their types and abundances. Facilitate of the identification of the mineral within the rock and the determination of their types and classifications. Textual analysis help to understanding the relationship between the minerals and sequence of mineral growth and overall texture of the rock. Optical properties. Optical properties. Petrography under the polarized light reveal the optical properties. Formation condition. Provide the insight into the condition under which the rock formed, such as the pressure, temperature and the presence of the fluids. Petrology enhances the precision of the rock analysis, offering the closer view of the mineralogical detail, contributing to the comprehensive understanding of the petrological characteristics and the geological history of the rock. Application in the petrology. Mineral resource assessment, oil and gas exploration, construction, minerals. Fourth is the geological mapping. Fifth is the environmental impact assessment. Sixth is the archaeological studies. 7 is the volcanic studies. 8 is the tetraconic and the plate tetraconates. 9 is the environmental monitoring. 10th is the education and the research. 11th is the groundwater assessment. 12 is the reservoir characterization. 13 is the soil studies. Next is the cultural heritage conservation, medical geology, hydrothermal system, climate reconstruction, geothermal resources, landslide hazard assessment, remote sensing and planetary geology. These all are the application of the petrology. Now we are seeing the petrology and technology how combined, and it's help us. Technological advancement of the petrology enhance the precious efficiency and depth of the analysis and studying the rock and the minerals. These tools contribute the more comprehensive understanding of the Earth's composition, geological process and a history. First is the advanced image technique. Microscopy, digital petromorphic microscope provide the high resolution image of the section and detail of the morphological analysis. Next, scanning electron microscopy that also help us the how to identify. It is also help us the determine the morphological studies. TEM, a transmission electron microscopy. Its short form is the TEM or a TEM. It allows the imaging the atomic scale, providing the insight into the crystal structure at a very fine level. Next one is the X-ray diffraction. X-ray diffraction. That technology also helps us identify how to crystal are formed or arranged. X-ray fluorescence or XRF instrumental provide the rapid and accurate element analysis of the rock, contributing to the comprehensive chemical characterization. Next is the computed tomography, CT scanning. CT scanning is the help to determine the facilities to characterize their core analysis. Next is the remote sensing. That technology help us to provide the detailed information about the petrology. That means the satellite and the aero-based remote sensing technology include hyper spectral imaging, assist mapping surface mineralogy and lithology over the large area. Digital mapping and GIS, graphical information system. That technology help us to give the spatial information, enhancing and the creation of the detailed geological map. Machine learning and data analysis. That technique used to provide the computational methods such as the machine learning algorithm are applied for the data analysis, pattern analysis and the modeling of the petrology. VI reality and augmented reality. That technique help us explore the virtual outcrop of the geological structure. Virtual reality and augmented reality that's help us to providing or exploring the different geological structure and the geological survey area. So these are the many more technologies which are help us to provide the more information about the petrology. Thank you.